Alright, welcome to Chapter 5. We're going to start talking about forces. This is 5.1, talking about force and weight. Our objectives here are to explain the difference between weight and mass, and calculate weight for mass or mass from weight. Alright, here are assessment questions for this chapter. If you take a trip from Earth to the Moon, which statement below is correct? Your mass and weight both decrease. Your mass stays the same and your weight decreases. Your mass decreases, your weight stays the same, or your mass increases and your weight decreases. Hopefully by the end of this chapter you can answer these. Another one. What is the weight of this dumbbell in newtons? A person weighs 150 pounds. What is this weight in newtons? What is this person's mass in kilograms? And here are our terms. We have mass, force, weight, newtons, and pounds. Alright, equations. That Fw is going to be the force, which is your weight. Your weight is actually a force, and it is mass times gravity. Gravity is 9.8 newtons per kilogram for this. Weight is mass multiplied by the strength of gravity. At Earth's surface, the strength of gravity is 9.8 newtons per kilogram. Alright, Isaac Newton was the first person to explain why objects move the way they do. He based his law on the motion on two key concepts, mass and force. All matter has mass and takes up space. That's probably the definition you've always learned about mass, is that matter is that it's a mass that takes up space. A solid rock has mass, so do gases, and so do liquids. With your hand out of the window of a moving car, you feel the mass in the air pushing against you. If air did not have mass, your hand would not move as you're driving down the road. Measuring mass. The SI unit for mass is the kilogram. This object has a mass of 2 kilograms. You might think that we want to use grams because it would be the base unit for mass. It would be a gram, but we always use kilogram as our base. So anytime that we're doing any calculations, we need to make sure we're in kilograms. So what is a force? The concept of force is, the basic definition is a push or pull on an object. Pushing an object or pulling an object, you're creating an acceleration in the object because forces cause acceleration. Forces can cause an object to change its motion. Can you give you some examples of forces? They're showing you some here on the right. Examples of forces are weight, friction, tension, force from a spring, or electric force. These are all things that we're going to talk about this year. Units of force. Quantitative. Force is measured in newtons. It is measured in newtons. So when I'm talking about a force, it's generally accepted to be, like we said, the force of weight. The Fw is mass times gravity. So you have kilograms times meter per second squared. That is the same. These are the units because we had mass and gravity was meters per second squared. That unit is called a newton. So newton is equal to the kilogram meters per second squared. So 1 newton is the force required to change the velocity of 1 kilogram object by 1 meter per second in 1 second. So, and here is the breakdown again. 1 newton is a kilogram. That's the mass. That's the acceleration from gravity. You're also going to see in a little bit, force is also mass times acceleration. This is Newton's second law in the next chapter. Alright, weight is the force of gravity acting on an object with mass. How is weight different from mass? Mass is considered an intrinsic property. That means that the quantity of matter in an object, it doesn't change. Your mass will not change. Your mass does not change no matter where you are. If you're on the Earth, you have the same mass as if you're on the Moon, if you're on Jupiter. That does not change. Weight is considered an extrinsic property. Extrinsic, because it depends on the gravity that is pulling on you. Your weight changes if you go into space because then you would be weightless, but you would still have mass. So your weight depends on your location. We talked about in the last unit where on Earth we have gravity of 9.8 meters per second squared. We're on the Moon where it was a sixth of what it is on Earth, which was 1.6 meters per second squared. You would weigh less on the Moon than you do on Earth. Your mass is the same in both places, but your weight would be different. All right, weight versus mass. Mass is a scalar quantity, so it does not have magnitude and direction. It just has magnitude. So 60 kilograms, no direction. Weight is a vector. It has magnitude and direction. For objects on Earth, it always points straight down to the center of the Earth. So the force of gravity, your weight, is gravity pulling you straight down to the center of the Earth. So weight is the force of gravity acting on objects with mass. So here's how we will go about finding weight. And for gravity, we're basically using 9.8. 1 kilogram of mass weighs 9.8 newtons. This is roughly the mass and weight of a 1 liter bottle of water. So 1 kilogram times this. You can use, these aren't always the units you're going to see. You'll see meters per second squared there because it is an acceleration going down to get the 9.8 newtons. So force is a vector, so it has direction. The force of weight always points straight down. Ta-da! Pointing straight down. What changes if you bring the bottle to the moon? Would this change? Would that change? No. Would this change? Yes. The acceleration would change on the moon. So our calculation for the moon, the mass would stay the same, and now we have 1/6 the gravity pulling down. The pound is the English unit of force. The person standing on this scale is pushing down on it with a force of 125 pounds. That's what they're showing you right here. We normally here in the United States, we step on a scale and we see pounds. All right, 1 pound is about 4.448 newtons. The newton is a smaller unit of force than the pound, so 1 newton is 0.225 pounds. And 1 kilogram is equal to 2.2 pounds. 1 kilogram is 2.2 pounds. So if you want to figure out what your mass is, that's the way to do it. If a person has a weight of 125 pounds, what is her mass in kilograms? So if 125 pounds is 1 pound, our conversion factor was 1 pound to 4.448 newtons, you could then use this force is equal to mass times gravity. Well, you had the force here, and you need gravity here to convert it into this. When you know the mass of an object, you can calculate its weight. All you need to know is the mass, because gravity, as long as we're here on Earth, gravity is going to be 9.8. Whenever you know the weight of an object, you can calculate its mass. So if you know the weight of the object, how much it weighs in newtons, you know what gravity is here on Earth, so you could go backwards to mass. Click this interactive calculator on page 135. This will be working with weight. Use the weight calculator to check your work when solving problems on student assignments. You see these A, B, C, D, E, and F. I would like for you to work A, B, C, D, E, and F. All right, your mass stays the same and your weight decreases. What is the weight of this dumbbell in newtons? So we have 10 kilograms. We're looking for this. So the 10 kilograms multiplied by the acceleration of gravity gave me this. A person weighs 150 pounds. What is the weight in newtons? What is this person's mass in kilograms? So 150 pounds, our conversion factor was pounds to newtons, gave us 667 newtons. And then now we're going to take the 667, divide by gravity, that will give us our mass. Remember our weight formula. That's it for 5.1. See you in 5.2.